Let me give you one more example of placing a non-repeating pattern irrational square root. The square root of 37, 37 is a prime number. So we're going to be looking for roots on either side that are perfect. So we've got perhaps we know 5 squared is equal to 25, and 6 squared is equal to 36. That's closing in on it now. And 7 squared is equal to 49. So we can use this information. Let's see, we've got the square root of, let me give myself a little more room, the square root of 37. Okay, I'm going to use this one, the square root of 36, and the square root of 49. Those seem to be on either side of this 37. So we're going to say that as inequalities, the square root of 36 is less than the square root of 37, which is less than the square root of 49. In this case, we can rename these because these are perfect squares. So we would say that 6 is less than, we don't know the value of this prime square root, which is less than 7. So now we know that our radical 37 comes somewhere between the 6 and the 7 on the number line. If we were to think of this number line as, let's say, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49 over here, we can clearly see that 37, the square root of this 37, is closer to the 36 than it is over here to the 49. So on a number line between the values of, this was the square root, remember, of 36. This was the square root of 49. And we simplified those into 6 and 7. So the square root of 37 is closer to the 6, the square root of the 6. So I would put my x probably there. So we're using what we know about perfect squares to kind of sort of judge where these non-repeating decimals representing the square roots of imperfect squares might fall. You can get an approximation.